Good evening, 2021ers. This is Professor Kaufman. What follows is a brief overview that will further underscore how to get started on Project 3, on Problem 1, where you're doing some assembly coding, and will also apprise you to how you can start GDB to work on the testing programs that are associated with the code. This is tremendously useful as you might be trying to resolve why a particular test is failing, as it will allow you then to run the test and debug the live code that is executing during the test itself. This takes a little bit of a setup, but let us get underway and get some code that we might actually want to test. So on the right-hand side here, I have the terminal. Left-hand side, I have my text editor of choice, Emacs as usual. I'm going to bop up first to the bat update asm.s file, where I have nothing but the basics at this point. Set bat from ports is filled in with a little bit of template information that I pulled out of the specification. But I have at least arranged that each of the functions in here, for instance, set display from bat and bat update, have return statements in them. Now, depending on how you're doing your own development, this is sufficient to run the tests in most cases as soon as we get this bit of syntax worked out here, which presently is not working in set bat from ports. Alternatively, some of you may be working on the hybrid, where you are combining this assembly function, but have commented out the remaining assembly functions and are making use of uncommented C versions from a batupdate.c file. And I'll mention along the way how you can go about debugging those functions as well there. All right, first, let's just get this resolved right away, because over here in the terminal, as I would type make, I'll get complaints from the assembler. There's no such instruction move X, and that's on account of there's actually no move X. Now here, my intent is to move some global variable into a register of choice. And just to illustrate a bit of code, which may be of interest for you to work out, this is a good spot to discuss moving a global variable into a register, which is required especially in these functions, this first function. You'll recall back over here, and this is the project spec, that the prototype for set bat from ports has some documentation associated with it. It has to do several things. Look at this bat voltage port and the bat status port, both of which are global variables, and make some decisions and numeric conversions for them. First, if you're going to work with that global variable, you're going to need to get it into a register. And so let's do that. And I'll focus my attention first on bat voltage port, although the techniques that are to be used for it are the same for both those global variables. Now, there's a mention over here of a bit of syntax that's useful, and we'll discuss it in more detail as we move ahead in assembly. But for now, you can copy it as a sort of incantation. We'll learn the basics of the spell soon. It's that the global variable name has to go here, leading the rip, which is used as an indirect. So I'm going to nix this part, and then over here, make a copy of this text, just so I don't have to type it, and paste it in over here. I then have to make a couple of decisions about what size of move that I would want to use. And since I'm not recalling just at this point what bat voltage port is, I'm going to remind myself by looking over the header. That's up here in bat.h. If you scroll down just a little ways here, you'll find, bat voltage port is a short. And so you need to use a 16-bit move associated with that. Looking ahead, when you'd be extracting bat status port, you need to be aware that it is a character, so a single byte move is appropriate. So what I want over here, then in bat update asm.s, is a move W. That's a 16-bit move. And the destination register then has to be one of those 16-bit registers. If you've forgotten what those are exactly, then it wouldn't be a bad idea to jump over into the spec here and just scroll down to the handy-dandy diagram over here. Now I have a bunch of choices, and we'll favor blue registers, the caller save registers first. I recall that this function, setBat from ports, it takes an argument. So that first argument will be in the RDI family register. So maybe EDI, DI. If I remember right, it's a pointer, so it'll be RDI. But that leaves the remaining blue caller save registers available for use. So I might, for instance, pick the SI family register here. And since I need a 16-bit register here, the 16-bit SI, I'll plop that down here. So SI. And that move W should now be in syntactic shape to compile and run the tests. So I'll save my file, jump over here to the shell, and try another make again, and voila, we're good to go. At this stage, I should have a bat main function that's running. It's running entirely the assembly functions, and I might try to run it, for instance, here. Here's bat main. At which point it'll remind me, hey, you got to give me a voltage val here. This is the raw value in terms of the voltage units over here. And then either put it in volts or percent mode. So I might, for instance, try a bat mode of, let's see, 7,000, for instance. And we'll say in voltage mode here. Now this, of course, didn't do anything, and there's all kinds of wonkiness here. For instance, on calling setBat from ports, I get a negative 5 billion some return value here, which is absolutely no good at all. But we're now in a position where if I wanted to figure out, well, why the hell is this thing happening over here, I can actually do so because I have a program to debug. In this case, it's bat main. So there's nothing simpler in this case than running GDB on bat main, at which point I can set my arguments, for instance here, to 7,000 and V, and that'll be, a V. And then, for instance, if I want to debug this setBat from ports function, I'd break at that point. So break at setBat, and that should be enough. Get some tab setBat from ports here, and that should break it. Maybe put myself in TUI mode, enable, and maybe turn on the registers. So layout regis, and then run. To get a little debug info, and then we should be run here, and here we are at the very first line of this thing over here. Okay, so that's one potential way to do this. What's a little bit vexing about this is that it is not exactly reflective of the condition that you'll find in some tests. Here's what I mean by that. We're, in this case, running bat main, which has been provided to you up here. And this calls in sequence several of your functions. It also sets various global variables to be certain things. So you can see over here, there's some command line processing, but then some setBat from ports over here that's called, and then a set display from bat, and so on and so forth. Now, irritatingly, later in the test cases themselves, we'll actually test individual functions. So set display from bat is going to get called without ever doing anything else with various global variables set for that. I can demonstrate what I mean by that, as in I'll hit quit right here to get out of this debugging section and actually just run the test now. So make test prob1, and we'll see a bunch of these over here, which the alignment will look a little bad. Of course, they are all failing at this stage, but that's not a big concern because I haven't written much code yet. I won't bother to leave this out or let this run to completion. I'm just going to press Control C right now. Now, as indicated over here, each of these test results is shown in a temp file here. And there's some information in here that we'll want to make use of. And so let's say, for instance, I'm passing some of the tests, but end up failing here this 7,400 volts business, test number 3. If you jump into this file, test results prob1, number 3 results.temp, there's a few things that we're going to fish out from there. And that, after having run the tests, there should be a new directory. So if I refresh my directory, you'll see, yes, this test directory is down here. And if I jump down to that, you'll see here's all of these test results files that are in here. We're going to focus on this number 3, which is the 7,400 volts. So I will open that up in my text editor here, and you'll see it has the usual sort of setup of indications of why the failure happened, both an output mismatch and a problem according to Valgrind, as well as then additional information that lays that out in some more detail. For instance, here, 7,809,000,000, some big number got returned. Okay, so supposing we're focusing our attention on trying to debug this one, there's one important thing that folks often overlook that's up top. It is this program run up here. This is what the test case is actually running. And this up here, this test bat update business, this is the testing program that actually runs that code. You could look at that one if you want. It's not particularly necessary. So it would be here, this test bat update.c. And if you open it up, you'll see just a long list of conditions here where on the command line, a test name is passed in. So if it's set bat from port 0p, then this is the code that will be run. And if instead the test name was passed in as set bat from port 700v, the one we're actually running, then this code gets run. And you can see this stuff should match exactly what shows up in those test results. So what that means from the perspective of debugging is as follows. If I pull open again that test results file, I can grab this line of text here. I'll just highlight it and copy it. And then jump over to my terminal over here, paste that in with a Control-Shift-V. And if I run this thing, then I'll see the actual output associated with my test run here. This is what is not matching the expectation right now, but this is an individual run, and having a program along with arguments, I'm now in a position to actually run the debugger on this program. And as long as I set the argument to this, then I'll exactly simulate the conditions under which the test is running, and may eventually be able to figure out why this strange value is coming out. And it seems to come out a bunch of different times there. It keeps changing sort of arbitrarily, assign maybe I have some initialized value in there. Okay, so to do that, then, I'm just going to fire up GDB here. And the program that I'll debug at this stage is this one, this test bat update. So I'll make a copy of that. And I'll paste it in here. So GDB will be happy to run on that. And then, as I would want to set the arguments to match exactly run this individual test, I'll copy this argument up here, which is the name of it, set bat from ports with 7400V. And I'll set my args to be that. The quoting here is important because the test name itself is a string with spaces in it. And that's going to sort of matter to some extent, that this whole thing has to be taken as one thing there. But at this stage, then I'm good to go. That I were to run the debugger at this stage, I might get some prompts, but I should get sort of the same output that I would see on the command line. Again, strangeness here with the return value, which keep changing, more clues in that respect. I may as well put myself in TUI mode now in order to get the sort of basic setup that you're acquainted with. So enable TUI, layout with the redis, and then set a breakpoint at the function in my code that I am trying to debug. In this case, it was this set bat from ports function, although as you move ahead and you may debug further functions that appear farther down. So I'll break at set bat from ports, give this a run at this stage, and you can see the breakpoint properly hits this first executable line over here. Now, I can maybe poke around a little bit and say, okay, this is what the code looks like by pressing up and down on the arrows. And if I step an instruction here, I'll expect to see this SI register changed. It's labeled here with the 64-bit address RSI. And so if I step an instruction, ironically, it's the SI register and the sort of shorthand GB step instruction, also SI, as it were. And you can see the debugger is highlighting the fact that it changed over here, that indeed it is different than it was. But you notice that it still looks very, very bad. Doesn't look at all like what I would expect the arguments to it to be. Which if I move up just a little bit, so go up a frame and sort of check around over here, that the voltage port is supposed to read 7400 over here. At that stage, I might realize, ooh, I might have made a minor mistake here. And that, remember, these 16-bit moves they only change the low 16 bits of the register. And so if SI had some stuff in it, which it apparently it did up top, we'll only change this last little sequence over here with a 16-bit move. Furthermore, then, as I would step an instruction, I say I got to rerun a little bit here because GDB got just a little bit messed up here. If I step an instruction here, I'm about to return, but I haven't actually populated the return register, EAX, with anything in it. And so the value that it had previously, this 9 billion business up here, that's what is going to end up getting passed back as the return value from this function, which is not appropriate at all. So to that end, I have a couple things to fix up, which is not too bad. Let's first make a correction to this SI business. Knowing that I need to do a 16-bit move here, I will initialize the RSI register to 0 so that I get only these bits that I'm pulling out of the global variable in there. Let me do a move Q of $0 into RSI. That'll ensure then that this entire register is initialized with all zeros so that when I move this thing in, it'll be only the bits associated with this global variable bat voltage port that are in there. And also, I will move a 0 into EAX, which should set up its return value correctly. Now again, maybe I just want to shorthand check this thing quick. I'm going to suspend the debugger by pressing Control-Z. That's a trick I talked about in my other intro video. I've made changes to the code, so I'll need to recompile at this stage. Or, in brief, I can just redo a test quickly here. Let's see. I'm trying to remember what test number. Oh, it's test number 3. Okay, so let me take test parallel and I'll rerun this test num equal 3 here, and that'll be the one that's named over there. I don't expect to pass still, but I do expect a few other things to be different. And in that respect, over here, I'm at least getting a return value of 0 over here, now, which is good. Now, having recompiled, this recompiled the testing program, I should be able to foreground the debugger, get this back into shape here, and then I'll rerun at this stage. And I should see the new instructions over here. So for instance, stepping instruction now, RSI becomes a 0. And then as I move a global variable into it, step another instruction, hey, there's the 7400 that I was looking for. It was there, it was just at the low 16 bits previously, and there was a bunch of garbage up in front of it. That was no good. And then stepping one further instruction over here, I've got a 0, which is good. Now keep in mind, this is all running in the context of the testing program, that test bat update. And I'm getting exactly the conditions associated with that because I had earlier, let's see if I TUI disable, it's being a little turd now. Crap. Okay, GDB's unhappy with me right now because of my use of switching between TUI and so forth, but so I won't bother with that part. But it has to do with the fact that I had set earlier the command line arguments to be run this one individual test. Now, irrespective then of where you're running, whether it's the normal tests or the hybrid tests, for instance, you'll want to have a look again at these test results and look for near the top is a program that is given, that is running, is what's ultimately being run in the test case. If this thing says test bat update, then that's the one that you want to debug with a specific test being run. If it's instead test bat or test hybrid update or something like that with a similar argument, then run the debugger on that one to get exactly the conditions associated with the test. Figure out how to run the debugger, though, because it will make your job much easier. It's no longer a guess and check effort, but rather a sort of guess what the code should be and then actually get data from the register file as it runs so you can figure out what's going on there. Hopefully this renders folks with some assistance, and again, we'll be happy to help in office hours as you encounter problems. Just expect us to ask you to fire up the debugger to step through some of this stuff. Happy hacking all, and I'll see you in lecture.